In this video, I've put some practice questions on mechanical comprehension for you to prepare for the ASVAB test. When a football is thrown upwards in the air, what causes it to arc back towards the ground? Friction, wind resistance, gravity, or centrifugal force? The answer here is gravity. So gravity is the force that causes objects to be pulled back towards the earth. A 180-pound person dives off a 30-foot cliff. What is his velocity as he enters the water? Now, to solve this problem, we need to consider energy conservation, where the potential energy is equal to the kinetic energy. We know that the formula for the potential energy is just equal to the mass times acceleration due to gravity times the height, while the kinetic energy is just equal to 1/2 mass times the square of the velocity. So in this case, taking the sea level as reference for altitude, then on top of the cliff, the 30-foot cliff, the diver has only potential energy. So we can calculate for the potential energy. Okay, where the acceleration due to gravity here is equal to 9.8 meter per second squared, and the height is 30 feet. We can convert this to meters, because the unit for our acceleration due to gravity is meter per second squared. Okay, let's just convert the height to meters first. So we have 30 feet times 1 meter is equal to 3.28 feet. So that would be 1 meter per 3.28 feet. The feet unit here cancels out, so that would be 30 divided by 3.28. Therefore, the height here in meters is just equal to 9.146 meters. Or let's just plug in all the values to the energy conservation equation, where we equate the potential energy to the kinetic energy. So potential energy is just equal to mgh, and then the kinetic energy is 1/2 mv squared. The mass here cancels out, so we're just left with acceleration due to gravity times height equals 1/2 v squared. Then we can multiply both sides by 2 to get rid of the 1/2 here. So that would be 2gh equals v squared. So we are asked for the velocity here, then we just solve for v. So v is just equal to, we get the square root of both sides here, so v is equal to the square root of 2gh. Then we can plug in the values to the equation. So v is just equal to the square root of 2 times 9.8 meter per second squared times the height, which is 9.146 meters. Therefore, v here is just equal to the square root of 179.5 13.26, which is just equal to 13.39. We don't have 13.39 in our choices, but we have 13.4. That would be, we can round this off to 13.4. So the answer here is 13.4 meter per second. Which of the following describes the relationship between kinetic energy, mass, and velocity? We know that the formula for kinetic energy is equal to 1/2 mass times the square of the velocity. Or we can rewrite this as when we multiply both sides by 2, this would be 2 kinetic times the kinetic energy equals mv squared. So the answer here is this one. If a person weighing 60 kilograms sits on one end of a teeter-totter, the distance between the person and the fulcrum is 3 meters. How much weight is needed on the other end to balance the teeter-totter if the distance between the weight and the fulcrum is 4 meters? Now let's try to illustrate this problem before solving this problem. So let's say this is our teeter-totter and this is the fulcrum here. And the person is here. Right. Okay, the person weighs 60 kilograms and the distance between the person and the fulcrum is 3 meters. How much weight is needed on the other end to balance the teeter-totter if the distance between the weight and the fulcrum? Let's say this is the weight and we don't know how much this weighs. And the distance between this one and the fulcrum is 4 meters. Now to balance the teeter-totter, the torques on both ends of the fulcrum need to be equal. So the torque is calculated by multiplying the weight by the distance from the fulcrum. So let's assume here that the weight needed on the other end to balance the teeter-totter is, let's say, we let W, that should be in kilograms, be the weight needed on the other end to balance the teeter-totter. So the torque exerted by the person sitting on one end is calculated as follows. Okay, torque of the person equals the weight of the person times the distance of the person from the fulcrum. So let's just plug in the values given. We have 60 kilograms, that's the weight of the person, times the distance, which is 3 meters. Therefore, the torque of the person is just equal to 180 kilogram meter. Now, to balance the teeter-totter, the torque exerted by the weight on the other end must be equal. Therefore, that would be the torque of the person equals the torque of the weight. That we knew that the torque of the person is equal to 180 kilogram meter, which we previously solved. And then the torque of the weight is just equal to the weight of the weight, which is W, times the distance of the weight from the fulcrum, which is just equal to 4 meters. Okay, dividing both sides by 4 meters to get rid of the 4 meters here, and the meter unit cancels out. Therefore, the weight of the weight is just equal to 180 over 4 kilograms, which is just equivalent to 45 kilograms. Therefore, to balance the teeter-totter, a weight of 45 kilograms is needed on the other end, considering the different distances between the person and the fulcrum, which is 3 meters compared to the weight of the fulcrum, 4 meters. So the answer here is 45 kilograms. A shovel is an example of which class of lever? Third, second, a shovel is not a lever. First. The answer here is third. So a third class lever is used to increase distance traveled by an object in the same direction as the force applied. The fulcrum is at one end of the lever, the object at the other, and the force is applied between them. This lever does not impart a mechanical advantage, as the effort force must be greater than the load, but does impart extra speed to the load. And examples of third class levers are shovels and tweezers. A wedge converts force applied to its blunt end into force blank its inclined surface, parallel to, perpendicular to, along, opposite to. The answer here is perpendicular to. So the wedge is a moving inclined plane that is used to lift, hold, or break apart an object. A wedge converts force applied to its blunt end into force perpendicular to its inclined surface. In contrast to a stationary plane where force is applied to the object being moved, with a wedge, the object is stationary and the force is being applied to the plane. So the examples of a wedge include knives and chisels. An 80-pound child is sitting on one end of a seesaw. If another 80-pound child jumps from a high platform onto the other end of the seesaw, what will happen? So the force of the second child here landing on the seesaw will propel the other end of the seesaw into the air. So the answer here is this one. The first child will be lifted into the air but remain seated. Which of the following is not a unit of power? Watt, horsepower, Newton, volt, ampere. The answer here is Newton, since Newton is a unit of force and not power. And force is push or a pull. Which of the following is an example of kinetic energy? Bowling pin standing, shoes in the closet, leaves blowing, a book on a shelf. So all of the three choices here don't move except this one, leaves blowing. Which of the following is not a type of simple machine? Lever, pulley, screw, spring. The answer here is spring. So there are 6 types of simple machines. We have the pulley, lever, screw, wheel and axle, wedge, and inclined plane. 2 gears are connected and the smaller gear drives the larger gear. The speed of rotation will blank and the torque will blank. So connected gears of different numbers of teeth are used together to change the rotational speed and torque of the input force. If the smaller gear drives the larger gear, the speed of rotation will be reduced and the torque will increase. If the larger gear drives the smaller gear, then the speed of rotation will increase and the torque will be reduced. So in this case, the speed of rotation will decrease and the torque will increase. So the answer is this one. The smaller gear has 8 teeth and the larger gear has 16 teeth. When the larger gear makes 12 revolutions, how many revolutions will the smaller gear make? So the gear ratio here is 2:1, because we have, for the small gear, has 8 teeth and the larger one has 16. So the ratio is 2:1, meaning that for every revolution of the larger gear, the smaller gear revolves twice. So if the larger gear revolves 12 times, therefore the smaller gear will revolve twice as many times. So the answer here is 24. So 12 times 2. A truck's wheel with a diameter of 18 inches moves another wheel with a diameter of 9 inches. What is the mechanical advantage of the system? So reducing the diameter ratios here, the ratio of the diameters would be 18:9. We can reduce this to by dividing both 18 and 9 by 9. So we can reduce the ratio to 2:1. So the answer here is 2:1. You just have to divide both by 9, since both 18 and 9 are divisible by 9.